In today's class, we'll consider some more useful sequences. Second category, exponential sequences. Exponential sequences. First one, positive time in this category A, positive time exponential sequence defined by x of n equals a to the power n into u of n. We have to find z transform of a to the power n into u of n and the corresponding ROC also. We know that x of z by definition is summation n equals minus infinity to plus infinity x of n into z to the power minus n. Hence x of z equals summation n equal to 0 to infinity a to the power n into z to the power minus n. The lower limit becomes 0 because of u of n. Because u of n is 1 for n greater or equal to 0 and 0 for n less than 0. This implies x of z is equal to summation n equal to 0 to infinity z by a by z, a by z to the power n. Recall summation n equal to 0 to infinity a to the power n equals 1 over 1 minus a provided mod a is less than 1. In this case, what is a? A is nothing but a by z. Hence x of z is equal to 1 over 1 minus a by z. This gives z by z minus a. For finite length sequences, it was easy to find the ROC. What we did, for what values of z, x of z becomes infinity, those values of z we avoided. For infinite length sequences like this, if you want to find the ROC, then mod a less than 1 gives the clue. That means mod a, here what is a? A is what? A by z. Therefore ROC is modulus of a by z less than 1. This is same as mod z greater than mod a. Hence z transform of x of n, you have to remember like this. The x of n equals a to the power n into u of n. Has a z transform. This has to be remembered. Note, as a z transform, x of z equals z by z minus a. ROC is also to be remembered, mod z greater than mod a. I am going to put this, I am going to draw the pole zero diagram. Please watch. Z plane is a complex plane having real axis, real of z. Imaginary axis, j times imaginary z. Let us assume that the entire z plane is inside this rectangle. I am going to draw a circle. I am going to draw a circle of radius equal to a. Equation of the circle is mod z equal to mod a. Equation of the circle in complex plane is mod z is equal to mod a. Now, what are poles? Roots of the denominator polynomial are called poles. Z minus a equal to 0 gives you the pole at z equal to a. The radius of the circle is what? Radius of the circle is a. We have got a pole at z equal to a. This gives the 0. This is the z equal to 0 gives the 0 at the origin. What is the ROC? Mod z greater than mod a. That means the region outside this circle is the ROC, which I am showing hatched here. This is the ROC. ROC is the region exterior to this circle. So the hatched region is the ROC. ROC is mod z greater than mod a. Please note that poles form the boundaries of ROC. That means the circle is passing through the pole, not through the 0. Second thing is, when z equal to a, x of z becomes equal to infinity. That means no pole can lie inside the ROC. That means pole has to be either interior to the ROC or exterior to the ROC. It cannot lie within the ROC. Very, very important. Therefore, an infinite length positive time sequence has an ROC mod z greater than mod a. For this sequence, you see, pole is interior to the ROC. Correct? This has to be remembered. Also, again, stress, poles cannot lie within the ROC. In this case, when z equal to a, x of z becomes equal to infinity. Therefore, pole cannot lie within the hatch region, which is the ROC. I just write these important points. Poles cannot lie. Poles cannot lie within the ROC. Within the ROC, very important. In this case, when z equal to a, x of z becomes equal to infinity. Second one, poles form the boundaries. Poles form the boundaries of ROC. Third one, for an infinite length, sequence, x of n equals a to the power n into e of n. The ROC is mod z greater than mod a. Next, I am going to consider negative time exponential sequence. Negative time exponential sequence. Second one, B, negative time exponential sequence. What is it? X of n equals minus a to the power n into u of minus n minus 1. Please note that it is called negative time exponential sequence not because of this minus sign, because of u of minus n minus 1. We know that u of minus n minus 1 is either 1 or 0. When it is 1, when minus n minus 1 is greater than or equal to 0, or minus n greater than or equal to 1, or n less than or equal to minus 1. 0 for minus n minus 1 less than 0, or n greater than minus 1. Hence, what is x of n? X of n equals minus a to the power n for n less than or equal to minus 1, 0 for n greater than minus 1. We know that x of z by definition is summation n equals minus infinity to plus infinity x of n into z to the power minus n. This implies x of z is equal to, I will split the summation into two parts. Summation n equals minus infinity to minus 1 x of n z to the power minus n plus summation n equal to 0 to infinity x of n into z to the power minus n. This means n greater than minus 1. This summation stands for n less than or equal to minus 1. For this summation, x of n is what? Minus a to the power n. For this summation, what is x of n? 0. Therefore, we get now this summation will be 0. Hence, we get now x of z is equal to summation n equals minus infinity to minus 1. What is x of n? Minus a to the power n into z to the power minus n. Next objective is to make the limits of summation positive. For that, we use a substitution. Put n equal to minus m. When n equals minus infinity, m is plus infinity. When n equals minus 1, m equals plus 1. Accordingly, this equation gets modified as x of z equals summation m equals infinity to 1 minus n and take outside the summation a to the power minus m z to the power m. Summation limits can be interchanged. So I write minus summation m equals 1 to infinity. This is z by a to the power m. Recall the formula. Recall summation n equal to n naught to infinity b to the power n equals b to the power n naught by 1 minus b, provided mod b is less than 1. Here what is b? Here what is b? Here b is equal to z by a. A equal to z by a. Therefore we get what is x of z now? X of z is equal to minus of z by a to the power 1 divided by 1 minus z by a. So this becomes now z by z minus a. See, earlier sequence also had the same z transform, but ROC will be different now. To get the ROC, what we have to do? We have to make use of this condition, mod b less than 1. What is b here? Z by a. Therefore, ROC is obtained by putting the condition modulus of z by a less than 1, which implies mod z less than mod a. So note, first one, a to the power n into u of n has a z transform z by z minus a. What is the ROC? ROC is mod z greater than mod a. Second one, minus a to the power n u of minus n minus 1. This has a z transform z by z minus a. What is the ROC? ROC is mod z less than mod a. Please note, two different sequences in time. I got same expression in z domain, but their ROCs are different. Therefore, if you find z transform of a sequence and do not mention its ROC, the solution is half done. If you want complete solution, ROC has to be written, because many time domain signals will have same z domain solution, but ROCs are different. This aspect I told earlier. Now I indicate my stand. Indicate my stand. Next sequence, third one, trigonometric sequence. Trigonometric sequence. Trigonometric sequences. Before going to this, one thing I forgot to tell you in the previous one. For previous one, whatever was x of z was z by z minus a, and what was the ROC? Mod z less than mod a. If you draw the pole zero diagram, this explanation is for the previous one, that is negative time exponential sequence. Z plane is a complex plane, real axis, real z, imaginary axis, j times imaginary z. The entire z plane is supposed to be contained in this rectangle. I draw a circle of radius equal to a. What is the ROC? What is the equation of the circle? Mod z equal to mod a. What is the ROC? Mod z less than mod a. That means ROC is interior to the circle. In the previous case, it was mod z greater than mod a. So this is the ROC. What is the ROC? Mod z less than mod a. Now put the pole. This is the pole at z equal to a. The 0 is at the origin. This pole at z equal to a is exterior to the ROC. In the previous case, it was interior to the ROC. Okay, the pole is exterior to the ROC. Now we go to trigonometric sequences. First one in this, x of n is equal to sine omega naught n into u of n. This is capital Omega stands for digital frequency. Recall what is sine theta? Sine theta equals e to the power j theta minus e to the power minus j theta divided by 2j. Therefore, x of n equals e to the power j times omega naught n minus e to the power minus j times omega naught n divided by 2j into u of n. We know that x of z by definition is summation n equals minus infinity to plus infinity x of n into z to the power minus n. Hence x of z equals, because of this u of n, the lower limit of summation will become 0 to infinity, e to the power j times omega naught n minus e to the power minus j omega naught n divided by 2j into z to the power minus n. Now this summation I split into two summations. This implies x of z is equal to 1 by 2j into summation n equals 0 to infinity. I combine these two. E to the power j times omega naught z to the power minus 1 whole to the power n minus, I combine these two, e to the power minus j omega naught z to the power minus 1 whole to the power n. Recall summation n equal to 0 to infinity on a to the power n equals 1 over 1 minus a, provided mod a is less than 1. Please note that mod a less than 1 will always give you the ROC x of j. Hence x of z is equal to 1 by 2j into, for this summation this is a, so what you get, 1 over 1 minus e to the power j omega naught z to the power minus 1. What is the ROC for this? ROC is what? Mod a less than 1. Therefore modulus of e to the power j omega naught z to the power minus 1 less than 1, or modulus of e to the power j omega naught is 1. This is same as modulus of z to the power minus 1 less than 1, or this is same as mod z greater than 1. Please note, modulus of e to the power plus minus j omega naught is modulus of cos omega naught plus minus j sin omega naught, which is root of cos square omega naught plus sin square omega naught equal to 1. Therefore, modulus of e to the power j omega naught is 1. Therefore, this has got reduced to modulus of z to the power minus 1. In simple words, this sequence has got an ROC mod z greater than 1. Minus, I'll apply this formula to this also. So you get 1 over 1 minus e to the power minus j omega naught into z to the power minus 1. What is the ROC of this? ROC of this is modulus of e to the power minus j omega naught z to the power minus 1 less than 1. This also simplifies to mod z greater than 1. Mod z greater than 1. This implies, please watch, this implies x of z is equal to 1 by 2j. Z to the power minus 1 is 1 by z. Therefore, this becomes z by z minus e to the power j omega naught minus z by z minus e to the power minus j omega naught. Both these have got same ROC. ROC of both is what? Mod z greater than 1. Now take LCM. This implies x of z equals 1 by 2j. Take LCM. This gets multiplied by this factor. You get z square minus z into e to the power minus j omega naught minus z square plus z into e to the power minus j omega naught divided by z square minus z into e to the power minus j omega naught minus z into e to the power j omega naught plus 1. Z square cancels. So this I can write as z. If you take common between these two, you get what? You get z into e to the power j omega naught. Z into, this is plus. This term I am writing here, e power j omega naught minus e power minus j omega naught divided by 2j. This 2j is nothing but this 2j divided by z square minus z. Between these they have taken z common. So what you get? E to the power j omega naught, e to the power j omega naught plus e to the power minus j omega naught. Divide by 2, multiply by 2. That doesn't change sanctity of the equation. Plus 1. Plus 1. So what happens? This in turn implies x of z is equal to, x of z equals, this is nothing but z into sine omega naught divided by z square minus 2z, this is cos omega naught plus 1. What is the ROC? ROC mod z greater than 1. Similarly, x of n equals cos omega naught n into u of n will have a z transform z square minus z into cos omega naught divided by z square minus 2z cos omega naught plus 1. ROC being mod z greater than 1. This you can take as a homework and try. This is the result.